Good morning, Amy. How are you doing?
Good morning, sir. Yeah, I'm doing well. How are you?
Very good. So, how is your year 13 beginning?
Not too bad. They always kind of start easy and then gradually get harder as I go throughout the year.
Very good.
But oh yeah, we're starting in school. I've got two teachers. So one teacher's doing the algebraic side of things, like algebraic fractions, partial fractions, and proof and stuff. And then the other's doing like sequences and series.
Okay.
So yeah.
So, what will you like to do today?
So we haven't really started these concepts. I just wanted to grasp it before I kind of do stuff in the lesson. So do you think we could go through like the whole partial fractions kind of concept and just algebra stuff?
So, I'll pull out one of my lessons on partial fractions, right? So, we'll get into that. Let's see if that is useful to you. So, let me share the screen with you. So, can you see my screen?
Just loading. Oh, yeah. It says extensive examples.
Correct. Extensive examples. Yeah. So what I did was that I do have a playlist on partial fractions. You could always get into that playlist,
right,
which will give you many examples, all different types of questions to be solved. So I'll share that playlist with you at the end of this class today. But now let me tell you what really partial fractions are and how do we use them. Most important application of partial fractions is in calculus, which you are going to do in the later half of your year 13.
Right.
So especially in calculus, when we do integration. So if there are, some rational functions, as we will see now, integrating these rational fractions is very difficult. But if we split them and write into smaller simplified rational functions, then integration is very, very easy. Straight away, the answer is log of that function, right? It's very easy.
Oh, I see. Yeah.
So that way is a very good technique and widely used. Well, there are so many other applications also, but in integration, I find major application.
Yeah.
When we say partial fraction, what does it really mean? Let's try to understand that. So let me take an example. Let's say we have example 4 here. Do you see this example 4?
Yeah.
Which is written as 5x squared plus 6x plus 5 divided by x plus 1 times x squared plus 2x plus 3. Correct? So the idea here is to write this complicated rational function into smaller chunks of simplified rational functions. Now, when I say simplified rational function, it means what? It means that we only have one factor in the denominator, any one, right? So that means which will lead to 1, 0, right? So we could have more order of that. That means I could have, like you see here, x minus 1 whole square also, correct? But the 0 is only at 1, correct? Its order is 2, it's a different story. So we simplify it so that we have some constant in the numerator and one of the factors. Constant in the numerator, one of the factors.
Right.
Well, that is the case when the factor is linear. If the factor in the denominator is quadratic, in that case, we get linear term in the numerator. So basically, in the numerator, we have 1 degree lower.
Yeah.
Then it becomes simplified. You get the idea. So that is the whole idea. So we could split, for example, x plus 2 divided by x times x minus 1 whole square. So the standard way is write them as 3 terms, right? First term will be a over the first factor, which is x in this case. Second will be b over the second factor, which is x minus 1. And then x minus 1 whole square is also a factor. So we'll take x minus 1 whole square. But since this is quadratic in nature, the numerator will be like a linear function, cx plus b. You get the idea.
Makes sense. Yeah.
So that is what it is. I'd like you to read these 3 bullets which we have marked. Can you please read? We'll just try to understand them.
Yeah. So decomposition of rational expression as sum of simple rational functions.
Correct. So like simple rational functions, like a simple, you see fraction, you understand? We simplify it, right?
Okay.
Write it in the lowest terms. That is what we mean. Now, when I say simple rational function, it means this. Can you please read this?
Degree of the numerator is at least one lower than the degree of the denominator.
That is important, right? But here, for example, you see a rational function where degree of the numerator is x cube means 3, right?
Yeah.
But the degree of the denominator is 2. So
Lower,
this is
yeah.
not simplified at all, correct?
No.
Degree of numerator, it's like a improper fraction. You get the idea.
Right,
So
right.
loosely, you could use the term like improper fraction. So we could simplify it. How
Yeah,
do you
yeah.
simplify it? You will simplify by dividing, correct? So you get some fixed part and then some fraction part. You get the idea.
Yeah, yeah.
So you remember you did polynomial division. So we have
Yes.
polynomial division in such cases. Then you can get one of these forms as written here, and then we'll further split into smaller sum of smaller rational.
So that's so those ones are kind of like a two-step process. You have to first do the division, then the partial factoring.
Okay. So I've written here special cases. If the numerator is of the same order or one higher or higher, we have to first divide it. So quotient will come here as equal to some quotient, right? And then plus the partial fraction. Is that clear?
Yeah,
that's
yeah.
the whole idea. So that becomes a special group when we will say that it is not a proper rational expression. Is that clear to you?
Okay.
Okay. So in some cases, we could adopt very simple techniques also. So let me just tell you a very simple technique on this special division. Some students are not familiar with polynomial division. So that is why I'll show you one special technique. So we have like 2x plus 3, right? We have 2x plus 3 divided by x plus 5, correct? We could, of course, divide it and get the remainder. The idea is to get the remainder, right? But what we could do is, we have to cancel x plus 5 some way or the other so that we get the whole number. You get the idea? So
at the bottom.
Yeah, I mean, in the numerator also, term x plus 5. Let me just show you. So I could write this as 2x plus 10. If I write that, I get x plus 5 there. Let me just show you this how. So it is 2x plus 3. If I add and subtract 7, what happens?
You get...
I will tell you why I did this. I get 2x
7 minus 7 is
0, right? So we are adding, subtracting the same term, correct? So basically what really happened was that I have now factored 2 and I got x plus 5. Do you see this? So both could be divided now, x plus 5 with x plus 5. You get the idea? So this x plus 5 cancels, and I've already written this in a simplified form, which is 2 minus 7 over x plus 5. Do you see that? So
yes.
I did not use division in this particular case. You get the idea? Because, you know, I teach students worldwide, and some students at this stage have not learned polynomial division. So they can adopt such a method, correct? Now, since you know what polynomial division is, you could do it straight. For example, I mean, that was very simple. 2x plus 3, we need to divide by x plus 5. It'll go 2 times, correct? So when it goes 2 times, you get 2x plus 10, correct? And you take away, and you get what? You get minus 7, right? As a remainder, correct? And therefore, you could write this as this. Is that clear to you?
Wait, so what's that method called?
This is also factoring. In a way, it's a combination of factoring, right?
Okay.
So we factored in a way so that we could get this. This is, of course, division, right? So we did division here and got a result. Quotient plus remainder divided by the divisor, correct? So you get the same thing.
Does that method that you've done on the right-hand side only work with like linear over linear, or can it be anything?
It can work with quadratics also, right? But the thing is, you need more strategies to work with. It's not that simple. Division is very simple. Even for linear over linear, do you see this division is one-step process, correct? I straight away divided x plus 3 by 2, and I got remainder as minus 7. So I have quotient of 2 minus 7 is the remainder, minus 7 divided by, I have to further divide it by x plus 5, right? So 7 divided by x plus 5. So straight away, I have written it as a partial fraction. Do you see that?
You went straight to it, yeah.
it is much simpler. So if you know
Yeah.
division, it is one step process. If you don't know division, well, it may take longer, but still you can do it. The idea is you can still do it, right?
Yeah.
That's the whole idea. So you could do it. But well, in the other two cases, we will see how to perform the long division. And those who
Okay.
don't know about that process will learn, because it's not difficult, correct? I'll explain
Yeah.
each and every step. So
Okay.
let's take some simple examples. For example, we have 5 over x minus 4 times x plus 1. When we say that partial fractions of this, we want to write this as a over x minus 1 plus b over x minus 3. You get the idea. Both are linear factors, and therefore the numerator will be a constant, right?
Wait. So where did those values come from?
We will calculate a and b values. That is
I mean the denominators.
the factors in the denominator, right? If you are given a quadratic equation, you can factor it, okay? And then each factor will give you one term at least.
All right. Okay.
Right? So if the degree is power is higher, then we get one extra term.
Mhm.
We will see
Yeah.
those examples. So that's the whole idea. Okay. So can you please read these 3 points once again?
Yes. So decomposition of rational expression as sum of simple rational functions.
Yes.
The degree of the numerator is at least one lower than the degree of the denominator.
Correct.
And the denominator factors have at most one real zero, and multiple orders is acceptable.
Yes. So in this particular case, you will notice that we have x plus 2 in the numerator, and the denominator is x times x minus 1 whole square. Right? So that means we will get one factor because of x, one term, which is a over x. Then we'll get the other term, b over x minus 1. And the third term, which now we have x minus 1 whole square. We'll treat that also as one of the factors. And since this is quadratic, we'll have linear on the numerator, cx plus d. We will find values of a, b, c, and d algebraically. I will show you how. Is that okay?
Okay. Yeah.
Perfect. So let's go with the first example, which is very simple, and that format will be adopted in solving all others, right? So let's say we have 5 over x minus 4 times x plus 1, right? So I want to write this as a over the first factor, x minus 4
X
plus b
minus
over
4.
x plus 1, correct? So the method here is that you multiply both sides by the common denominator. So what is the common denominator here? X plus 4 times x plus 1, right? So you multiply each by x plus 4 times x plus 1, right? Every term, right? So this also will multiply, this also will multiply by x plus 4 times x plus 1. And this also will multiply by x plus 4 times, let me write here, x plus 1. Is that clear to you?
Yeah.
So you've done same thing on all the sides, and therefore you've not changed the equation. It is exactly same equation. So on this side, as you can see, these factors cancel away, and what you get is just number 5, right?
Yeah.
In this side, we are dividing by x minus 4, not plus 4. Sorry, x minus 4 is in the denominator, right?
Yeah.
X minus 4, not plus. Okay, so we are left with a times x plus 1 plus b times x minus 4 in the equation. So denominators have cancelled because we multiplied by common denominator. That is how you also work with fractions, correct? Similar concepts, right? Now look here. If I put x equals to minus 1, then what happens?
The bracket
A will be 0, right? So
yeah.
a times minus 1 plus 1 means a is 0 now, plus minus 1 minus 4. So we can say 5 is equal to, I mean, this is b times, correct? So minus 1 minus 4 is minus 5, minus 5b. Is that okay? So that when you divide 5 by minus 5, you get minus 1, which is the value of b. Is that clear to you? So you got the value of b as minus 1. On the other hand, if I substitute x equals to 4, then what will happen? Then b term will be 0, right? So we get 5 equals to a times. If I'm substituting plus 4, this was x plus 1. So 4 plus 1, that is 0, right? So we get 5, and this is a5. So a is 5 divided by 5, which is 1.
One.
So we
Yeah.
do get this as equal to a equals, let me write down here, a equals to 1 and b equals to minus 1, correct? So we could write this term as, let me just write down the final answer, 5 over x minus 4 times x plus 1 is equal to, the value of a is 1, so 1 over x minus 1, and b is minus 1, so I'm writing minus here, and 1 over, we have x minus 4, sorry. This is x plus 1. That was typing error. Was it the same question? Yeah, I wrote it wrong. So sorry. So x minus 4, and this is x plus 1. Is that clear to you?
Yeah. And we have to write that last statement. We can't just leave it like a equals b equals.
No, we have to write it clearly.
Okay.
So we found the value of a and b, and the idea here is you can select the value of x so that one of the factor is 0, and then the other unknown b can be found.
Right.
So that is the whole idea. Okay. Now, as you can see here, these examples, I've already shown you how to do question number 5, which is 2x plus 3 over x plus 5. Numerator degree is same as the denominator degree. That means we could divide them, right? And we divided, got a constant 2 minus 7 over x plus 5. We've done the partial factor. Let me take a complicated case now. I'll take example number 6 now, which has 4x squared minus 16x minus 7 in the numerator and 2x squared minus 9x plus 4 in the denominator, correct? So we are going to take this term. I'll show you the process of long division, and then we'll get a remainder, and that part we'll do partial factoring just as I did, for example, 1, okay?
Okay.
Now, here is our second example, which is example number 6, actually. 4x squared minus 16x minus 7 divided by 2x squared minus 9x plus 4, right? So when we divide, we will get some constant in the numerator since the degrees are same. Do you get the idea? Degrees are same.
So if the degrees weren't same, you wouldn't have k there.
Yes.
Okay.
Yeah. So now, long division is kind of like this. Let me just show you here, and then I'll show you what we have done already. So we have the numerator, which is 4x squared minus 16x minus 7. We're going to divide this by the denominator, which is 2x squared minus 9x plus 4, correct? So 4x squared goes 2 times, correct? So we'll write
2 times.
So 4x squared, 2 times 9 is 18 with a minus sign, and this plus 4 times 2 is plus 8, correct? And then you do take away as you do in division, correct? So when you take away, first terms become 0, right? And here we get minus, and that is minus 18 becomes plus, so you get
2x.
And this gives you minus 15, correct? So that becomes your remainder. So you could write that expression as equals to the quotient 2 plus the remainder, which is 2x minus 15 divided by the quotient divisor, which is 2x squared minus 9x plus 4. Is that clear to you?
Yeah.
So we have written this in proper expression, rational expression. You get the idea. So I'm just showing you the long division once again here neatly. So basically we write the numerator and we divide that by the denominator. So that becomes a divisor. Idea is to cancel away the first term first. Since it is 4x squared and this is 2x squared, I should be multiplying it by 2, correct?
Yeah.
When I multiply by 2, I do get 4x squared, and clearly they cancel and we have a 0 there, correct? Now, the rest of the terms, we have minus 16x minus 7, as I showed you, over minus 18x plus 8. When we take away those, we get 2x minus 15. So we can now write this as 2, the quotient, plus remainder divided by the divisor. That is how we can write. So we have done, we have simplified to one extent, one level, the rational expression. Is this step clear to you?
Yeah, yeah.
Now, the denominator in this particular case is not in the factored form. So let us factor the denominator, which is 2x squared minus 9x. Well, we can look into product and sum. What is 2
Right.
times 4? 8, right? 2 times 4 is 8. So we want minus 9. We'll do minus 8 and minus 1, correct? So product and sum. We are using product and sum method, correct? So product or sum, we're looking for 4 times 2, which is 8. And it could be written as minus 8 times minus 1. And therefore, I've split 9x into the two terms as minus 8x and minus x. It is minus 9x, correct? Now you can do group factoring. 2x times x minus 4. Here you can take minus common, x minus 4. And finally, we have factored the denominator as x minus 4 times 2x minus 1, correct?
Yeah.
So we have this term as factored form 2 because we had the 2 as the quotient, and the denominator has now been factored. Since the denominator has been factored, we could now write this as sum of two other rational
Oh, I
as
see.
2 plus a over x minus 4 plus b over 2x minus 1. Is that clear to you up till now?
Yeah.
Now
Yeah.
what we need to do is find the value of a and b, right? What is a equal to and what is b equals to? Clear?
So
Up till now it is absolutely clear, right?
yeah, very clear.
So with this, we will also learn how do we do partial factoring for an expression which is kind of linear over quadratic. Do you see that? So
Yeah.
we are learning that also, correct? I had purposely kept like this so that you understand all different methods just by using one example, right?
Right.
Okay, so let's now look into the second part of it, which is how do we get the value of a and b? Can you help me in this? Because we just did this for a very simple example, correct? So what should
Yeah.
be the first step?
So it's the common denominator
Which
is
is
the
product of
2x squared. Yeah. So now we factored it. So but it is that factor when you expand. So we just need to multiply the a by the 2x minus 1 and multiply b by x minus 4. Because yeah, if you do the whole thing, it just cancels because the denominator is the same. And then then you get the numerator values only because all the denominators are the same now. So you got 2x minus 15 equals a 2x minus 1 plus b x minus 4. Then you have to let one of the brackets equal 0. So in this case, you would let x equals a half and to find b, and then you do x equals 4 to find a.
Correct. So if you put x equals to half, you get what? Half times 2 is 1, right?
1
minus 15 equals to a times half
That's
is
0.
1 minus 1, this is 0. And here if you do half, then what do you get?
Minus 4. You get a value.
This is 2x, x minus 4. 2x minus 1 half x minus 4. Is it correct? Okay.
Minus 2 over 4. No, that's not right.
So half means if you take away half, 3.5, right?
Yeah.
So it is minus 3.5.
Minus 3.5.
So if you do 2, it becomes 8, right? So 1 minus 8 is 7 over 2, right?
Yeah.
Is it clear? 3.5.
Yeah.
We did this side is like, so we have here minus 14, correct?
Yeah.
Equals to
minus
7 over 2b. Is it
b.
not very difficult? I mean, of course, so when fractions come, you hesitate, right? So probably I've taken such an example, which is not straightforward. This is a very good example, right? So you can find now the value of b. So what is b equals to? You can say b is equal to, you can multiply by 2 over 7. Let me do it on the right. Let me do like here, right? So we can b equals to, so minus will cancel. So you get 4 times 2 over 7, correct? So now what do you get? 7 times 14 times 7 divided by 7 is 2, right?
4.
You get 4, correct? So we get the value of b as 4. Is that clear to you? So this value of b, we can write this as 4. Is it clear? Okay. Now let's find a. To find a, I will substitute
x equals to 4.
X equals to 4. So you get 2 times 4, which is 8.
8
minus 15 equals to?
Minus 7.
Yeah, minus 7a. Is it clear? 8 minus 14 is? 8 minus...
I think it's just minus 7.
minus 7, right? So we substitute 4, right? 8, this is plus 7. Okay. This is plus 7.
I don't think there's any a next to it. I think it's just -7.
Yeah, minus 7 equals to 7, 8
Yeah.
on the right hand side, right? So when I divide this, I get -1 equals to a. Is that okay?
Yeah.
So we just substitute x equals to 4, got that value. So this
And then
8
sub it in.
minus 1. Yeah, this is -1. Is that clear to you? So we
Yeah,
are
yeah.
done. Since we have done this, we can actually go back to our main equation, which is x square minus 16x minus 7 divided by 2x square minus 9x plus 4. We had divided earlier to get 2 plus 2x minus 15 over 2x square minus 9x plus 4. And now we wrote this as this combination. Is that clear to you?
Yeah.
So that is how we could actually solve this. Is this clear?
Yeah, very. Makes
Let
sense.
me take one more example. So
Okay.
just to ensure that you have learned the whole thing. So we have done this particular question. Now we will take question number 7. Can you please read this question?
Yeah. So x cubed plus 5x squared minus 2x minus 19 divided by x squared plus 7x plus 10.
What will you do?
Okay, so it's an improper fraction. So first I'll just look at the degrees and see that the numerator is 1 more than the denominator.
Yes.
So then that means I know it would be like a 2-step process.
Correct.
So yeah, so you divide. But then I was just thinking the bottom one you can factorize into x plus 5 and x plus 2, but there's
You
no
can.
point doing that.
Yeah, we will do it later. To
Okay.
divide, we need the whole standard form. It's easy,
Okay.
right? Yes.
Yeah, yeah, yeah.
So
Let's do the full
division.
long division. Yeah.
Okay, so I've done the long division for you here. So here's this question: x cubed plus 5x square minus 2x minus 19 divided by x square plus 7x plus 10. So the numerator is written inside as shown here, correct? The denominator is written outside as shown here. Now, we have to focus on the first term, the leading term. So what is the leading term? X cubed. Here, the leading term is x squared.
Square.
How many times should I multiply?
X.
Simple. X times. When I multiply x times, I have to multiply x with all these terms, right? With all the
Right.
three, correct? All the three. When I do that, what do I get? I get all this. X cubed, 7x squared plus 10x, correct?
Yeah.
Now what I have to do is take away.
Subtract.
Right? Let's try to understand the division process, long division. So when you take away, they cancel. Here it is 0, right? On this side, you get minus 2x squared, and then you have minus 12x minus 19. Bring down 19, right? Minus 19 here, correct?
Yeah.
And further, you can divide by minus 2, correct? So when you divide by minus 2, these leading terms, they cancel away. Minus 2x squared and minus 2x squared. You get minus 14x minus 20. When you divide this minus 2, right? I mean, multiply that by the given divisor. Write it down, take away, and you get a remainder. What is the remainder in our case now?
2x plus 1.
2x plus 1. And therefore, we can actually write down the whole rational expression in a simplified form. We have
right.
x minus 2, a linear term as independent of any fraction, as a polynomial, right? So linear polynomial we got, which is same as the quotient. Do you see that?
Yeah.
X minus 2. So same as the quotient, which is right there, is one part. And now our exercise is to write this 2x plus 1. I should write like this, right? So 2x plus 1, which is the remainder, right? Let me color it in a different color. It becomes easier. Right. So we got this green part, which is the quotient part, right? Plus the remainder part. So this is the remainder. So we'll divide remainder by the divisor. That is what we have to do. And we have to write this as a partial fraction.
Partial fraction. Yeah.
You get the idea. So first step is long division. And in that first step, when we divided the numerator by the denominator, we got one term in which is a polynomial. You get the idea.
Yeah.
So we have now polynomial plus the rational expression. Now again, we have 2x plus 1 divided by x plus 5 over x plus 2. Now The two factors are x plus 5 and x plus 2. So they will have a constant term in the numerator, 1 degree lower.
Yeah.
Linear. 1 degree lower is a constant. So a and b will now be a constant. Now, how will you do it? What should be your next step? Can you tell me, please?
So is this where you try to get the denominators the same? So we multiply the a by x plus 2, multiply the b by x plus 5.
Correct.
And
So
then
you're
make
saying
it
that
equal.
very easy. So you'll multiply a by x plus 2, multiply b with x plus 5 because the denominators cancel. And on
Yeah.
the left hand side, you have
2x
2x
plus 1.
plus 1. And then what will you do? You will
So-
substitute. Yes, tell me.
Sorry, yeah, let x equal to minus 2 to find
b.
b, and let x equal to minus 5 to find a.
Once you do that, you have your answer. You said,
Right.
see that, right? So even if we have a improper rational fraction, we can actually rational function or an expression, we can still do it, right? So I did the
I see.
calculations for you for this particular question. Here are these calculations, right? Can you please go through them? We have
Yes.
expression.
So we've got the expression of 2x plus 1 over the factorized form, so x plus 5 times x plus 2, and that equals to a over x plus 5 plus b over x plus 2. Then we multiplied so a by x plus 2 and b by x plus 5, because then it cancels with the denominator, and we've got that equal to 2x plus 1. Then we want to make one of the factors 0, so you let x equal minus 5 to find a, and then you let so you just substitute it in and you get a as 3. And then to find b, you let x equal minus 2. You substitute it into all the parts where you see x, and you get b as minus 1.
Here.
And then substitute it back into the final answer.
So combine both these solutions, correct? So we began with cubic equation divided by the quadratic equation, which gave us a linear factor plus the two partial rational expressions as shown here. Do you see that? So that is how we could easily do all these questions, correct?
Yes, yeah.
So that's
That
the
was
whole
really
idea.
clear.
Yeah.
Yeah.
So I think we have learned the long division process also, and all those students who really do not know about long division now must have understood how do we do that, so that we could also take care of rational expressions where they are not proper rational expressions, right?
I also understood, yeah, because long division for me as well was a bit like sketchy. So like, yeah, you made it really clear. I like how you put, like, you know, when you take, so let's say you get x as the value on the top, you put it in line with all the x values to avoid confusion.
Okay,
So
the division process.
Yeah.
Yeah, that division process, you have a good look at it, right? So this one is neat, right? So,
yeah.
Amy, yes, what you're saying, we can go through it once again for the benefit of those who want to understand this division process. And that's why actually I did this complete solution. Yeah, can you explain how do we divide, Amy?
So you've first written out like really clearly, so the x cubed plus 5x squared minus 2x minus 19, and all the signs are with the numbers, just to be really like specific, and we're dividing it by x squared plus 7x plus 10.
Okay.
So we can see that the quotient, is that what it's called? No, it's divisor, sorry. The x squared, and we're trying to get x cubed, so we know we have to multiply it by x. All the terms, yeah. So we know that would be x cubed plus 7x squared plus 10x, and you subtract. So that will always cancel the first two.
Yeah.
So you get rid of the x cubed, and then you subtract. And when you subtract, make sure the signs are all right. So 5 minus 7, we get minus 2x squared. And then minus 2 minus 10x is minus 12x. And then you just bring down the minus 19.
Right.
And then, so we got x squared here, and we want minus 2x squared. So we just need to multiply it by minus 2, all the terms. And same process again. So it'll be minus 2x squared minus 14x minus 20. And we have to subtract those terms. So the minus 2x squareds cancel. The minus 12x plus the 14x, because the 2 minus, you get 2x, and then again, minus 19 plus 20 is 1. So that's the remainder.
So you could write now like this.
Yeah.
And then you do that partial factoring, right? Find the values of A and B as we did, and that's it. You see that? So that's an easy way of doing it. I think it's absolutely clear, Amy. Right?
Yeah,
So,
very straightforward.
yeah. So I'd like you to do some questions based on this from your book. And if
Okay.
there is any difficulty, let me know, right?
All right. Thank you so much, sir. That was
great.
really helpful.
So we'll end the
Right.
class here and look forward to if you need anything else, right? Okay.
Thank
then.
you so much, sir. Have a good day.